with that, we're switching to SQL Server 2019. So today I want to give you a brief overview. So basically what is coming in SQL 2019 and yeah, especially what you're already able to test within the private preview that was announced last week and that is available to all of you. So yeah, I will cover the most important or most interesting parts of SQL Server 2019, and yeah, try to show you some demos. And we will try to cover some of the things a little bit more in depth during our next past meetings. So Milos Radojevic will go more into detail about database enhancements, and yeah, I will go into depth with regards to the big data cluster. But today this should be more or less like an overview. So if you have questions, just feel free to interrupt me and to ask you questions. So yeah, basically SQL Server 2019 is really the evolution of what we started already with 2016 and 2017. So one of the most important things that we introduced with the last version, with SQL Server 2017, was really the platform choice, adding SQL Server on Linux and in Docker containers, and this we really try to kind of advance there because there were some limitations. Not all services were available, and we're constantly working on reducing this these limitations there on the platform choice. Yeah, some interesting things there, for example, with regards to containers, but I will cover that in a few minutes. Of course, when it comes to storage options, yeah, in memory computing, row store, column store plays an important role. So combining these different storage options and yeah, let you at the end of the day a choice what you use, depending on your use case. That's an important thing. And yeah, with regards to analytics, of course, we're also trying to kind of enhance the capabilities there. So we will see new languages beside Python and R that we already support within SQL 2017. And yeah, so that's are the most important things. So yeah, the main things or yeah, the main topics are the same for 2019 as there was in 2017. Of course, we have some yeah, we're focusing always on some things. So there might be areas where there is more investment for this version. This for SQL Server 2019, one of the I think most interesting things that is new is with regards to data virtualization. But of course, there are a lot of new features and a lot of new things across all the different areas of SQL Server. So let's start with the first new stuff. So one main area of investment of new things is regards of the integration of data. So what we've added is what I would call a data virtualization layer. The idea behind that is to really access data no matter if it's in SQL Server or if it's in non-SQL Server stores. With the last version, we introduced a technology called Polybase, which allowed you to connect to Hadoop systems and to query Hadoop out of SQL Server with T-SQL. So this was basically the initial technology that enabled us to really build this data virtualization thing. And all the things that I'm talking about now with regards to data virtualization basically relies on this Polybase technology. So this is basically what I would call version 2 of Polybase. And we are not limited now to only Hadoop, because it was really Hadoop only, and that's it. We're now enabling other databases, NoSQL databases, Spark, for example. So yeah, very, very interesting stuff. The next thing is really to make it more easier to use big data stores. And what we are introducing there is a thing called the big data cluster. So it's not only accessing the data, but also having a very easy way to set the stuff up. So providing out of the box Spark clusters inside Kubernetes within this thing called a big data cluster. Cover that in depth in a few seconds. And of course, enhancing the languages and the mechanisms you can use for advanced analytics and artificial intelligence. So what we're doing there is basically enhancing what is already there with regards of languages. So we're adding new languages there to have more choice and more possibilities to analyze your data without using classical T-SQL. So this is really about using statistical languages, using more high sophisticated languages to analyze your data at the end of the day. So as I already said, with regards to connect of your data, we're including, of course, relational data, we're including NoSQL data, and we're including big data stores. In terms of creating or generating intelligence out of your data, what you can do now by using the big data clusters is using Spark. So inside this big data clusters, we have basically Spark in combination with SQL Server out of the box. And another new thing that comes with SQL 2019, which is not really bound to 2019, is the Azure Data Studio. And as the name suggests, it's not only for Azure, so for the cloud-based services, it's also for SQL Server as well. And I'll give you a glimpse of what is Azure Data Studio all about. It's basically a platform-independent tool to manage SQL Server. So that's the basic idea. Of course, there is a long way to kind of feature completion to Management Studio, so don't expect that yet. But the long-term strategy is really to have kind of a version 2 of Management Studio. As of now, it's of course very limited in terms of what you can do out of it. But on the long run, it might when replace Management Studio. But that's really a long-term strategy at the end of the day. So in the short-term strategy, it's really a platform-independent thing where you can start managing SQL Server there. Okay, let's drill a little bit into the details. As I already mentioned, one of the new capabilities of SQL Server 2019, which is on the left side here, is the data virtualization. So basically, it's a little bit, let's call it a mixture or a new evolution of what we already had with link tables. When you know link tables in SQL Server, you could connect to different relational sources, basically, for example, an Oracle server, and query out of SQL Server directly the Oracle tables by defining this external table. So that the basic idea behind it is more or less the same, but it's not limited to relational sources anymore. So it's open, as I mentioned, to NoSQL databases. For example, you can directly link a Mongo database. You can directly link Hadoop file system, for example. And the second thing on the technology-wide is a little bit different. So it works a little different than this SQL Server, the old external table. So as I told you, we're using Polybase, and one of the advantages of Polybase is that your query engine is not your SQL Server where you're working in, but you have additional SQL Server nodes that does the querying. So we basically are able to scale out the querying of the other systems. So that's one important difference with regards to the old linked service. The managed big data cluster, this is a thing that consists of SQL Server, Spark, Hadoop file system, and even SQL data nodes. So the idea is basically to provide a very easy way to kind of store data that is not necessarily relational data into this big data cluster stores without maintaining your own Hadoop cluster, because that's not an easy task. So basically we set this cluster up for you. It's completely Kubernetes based, but we'll look into details afterwards then. And on the right side, you see this complete AI platform. So basically what we are doing now, we already had this machine learning services in SQL 2016, it was called R services, but now we support R and Python. So we enhanced this machine learning services with additional languages. We enhanced it with Java, so we can run Java code within SQL Server. And of course, with this big data cluster, we are getting Spark there as well. So you can use Spark and Spark machine learning to analyze your data as well. So there's a very powerful combination when it comes to advanced analytics and artificial intelligence. And with that in mind, combined with this data virtualization layer, you have really flexible what kind of data sources you're using. Okay, so how does this SQL Server Big Data cluster look like? So the basic idea is, on the one hand, you have a thing called the SQL Server master instance. That's basically your SQL Server where you might store your relational data as well. And one option is to directly query Hadoop file system out of the SQL Server. This is basically what you can do now with the Polybase stuff as well. But what we provide in addition is a so-called storage pool. The storage pools are Kubernetes based, so they are basically containers, and you run them on a Kubernetes cluster. So these are predefined containers that you can just scale out as you need them. So they are completely predefined. Inside such a container, we basically have these three components: SQL Server, Spark, and an HDFS data nodes there. So this is what's inside a container. So this is one approach, but if you need really more performance in querying, because the problem with this approach is you have basically one node that is querying your cluster, and if your cluster is very big, that gets at the end of the day very slow, and that's not the idea of big data technology. Of course, you scale out the querying as well. So in addition to that, we provide the so-called compute pool. It's the same concept as we already have with Polybase now. So you can also add these SQL compute nodes now to query out to scale out your querying for Hadoop in SQL 2017. But now you have these predefined compute nodes that basically directly connect to your storage node, and then you have a scale out querying of your data. Of course, you can combine that with external data. As I already mentioned in the first step, we have this kind of data virtualization that lets you not only connect to Hadoop and Spark, but lets you connect to literally any ODBC connection to MongoDB and to some other sources. For example, to external existing Hadoop clusters. What you typically do is you create another compute node and let the compute node do the querying. Typically, you create multiple compute nodes if you need multiple sources. So otherwise, you have a single point of performance issue maybe. So you can create additional compute pools that does this kind of external connect to this external data sources to do this data virtualization. And inside a big data cluster, what we provide as well is so-called SQL data nodes. So they are not the Spark and Hadoop part, but really the relational part. Sitting inside a container as well, and within this compute node, you can think of it kind of a sharding of your data, and can query this data as well out of a SQL compute node. That makes sense if you can have really data that you can really shard over different nodes, because if you put everything in one node, then it's maybe better to put it directly in the master node and not in compute nodes. But the idea is here to provide an option to do kind of a scale out of relational data as well. But you need to take into account how you kind of do the partitioning of the data at the end of the day, or the distribution of the data. And everything of these components are delivered within this big data cluster, SQL Big Data Cluster. So as you can imagine, because I'm talking about containers, except for the master instance, the things, even SQL Server there is Docker based. So it's SQL Server on Linux basically there. So if you're interested in trying that technology out, because that's not included in the public preview now, so we have a private preview up and running. So you need to kind of contact the guys from the product team to get into the private preview. So we already have some Austrian customers that are in the private preview. So it's absolutely possible to be inside the private preview. But yeah, as of now, you need to kind of ask for the bits. Yeah, another important part for SQL Server is and was and is always performance, security, and availability. Of course, we run really mission critical and high performance workloads. So yeah, there is, I would say, no SQL version that doesn't, that has nothing new with regards of performance, security, and availability. Same is valid for SQL 2019. We are again investing a lot in performance things. We have some interesting concepts with regards to security, with data, with kind of always encrypted technology and enhancement there. And for the availability stuff, it's especially for the container part, because if you run SQL now in Docker containers, now you have a little problem when it comes to how do you make SQL highly available inside containers. That's not so easy today, because you really need to integrate within the whole Kubernetes part and the whole container part. So at the end of the day, we are enhancing or enabling always on for Docker containers there, but I'll come to that in a few minutes. So first of all, let's talk about the so-called intelligent query processing. So we started, with SQL 2017, we started a thing that we call intelligent query processing, which is basically tries to address some of the issues you have with some special constellation when it comes to query plans and query processing. So there are, as you all know, there are some special combinations where your statistic is not up to date or not accurate, where we kind of need to do some estimations because we don't know what is really the resulted rows and so on and so forth. And there are different scenarios where basically the query processor, as it was in the previous version, is really doing a very bad job at the end of the day, and this is really generating query plans that are very bad and especially very slow. So we try to address this with intelligent query processing, because the problem there is always that in all of these scenarios, it's extremely difficult to kind of create a query plan in advance. That's basically the main problem to all these different scenarios. So what we are basically doing is kind of let's call it adaptive query processing, or put more intelligence, so that we, during the creation of the plan and during the execution of the plan, we kind of can adopt the query processing and the query plan. So that's the basic idea of all these different issues and all these different scenarios there. And as you see, there are some things that we already did in SQL 2017, and we have some new things coming now with SQL 2019 that will improve the query performance for some specific use cases. So another thing we are doing besides this intelligent query processing, we are always trying to optimize everything which is around I/O, because still not everything is in memory, and still not everything can fit in memory, of course, and accelerating I/O is always a big issue and a big topic there. So we're trying to really in the extreme bypass most of the I/O stack to be as fast as possible when it comes to reading data from disks. So there is a lot of investment going on there as well. And one very interesting thing is the lightweight query profiling. I don't know if everyone of you knows a lot about query profiling. Basically, it's nothing new there. We already introduced that in I think in 2017. So basically, but what you need to do is you need to kind of put it on. But what we figured out during our tests, and we have a huge install base using our SQL Azure databases, because we have over 4 million databases there that are generating a lots and tons of telemetry data. And what we figured out is that the impact of the lightweight query profiling and doing some optimizations there is really extremely low, the performance overhead, I would call. So what we basically now are doing, we turn it on by default, because it really makes life much easier. And only for, I would call, extreme performance workload, you can of course then turn it off. But basically it makes life much easier, and I show a short demo why the thing is really useful at the end of the day. But let's start with a demo around the query processing. And just to kind of show you some of the enhancement we did there. So what we focused on was on table variables, and the problem with table variables is that during the compilation time we can't really estimate what's in the table. So what we do is we say, okay, there is one row in the table, and that's fixed. And as you can imagine, depending on how much data is really then in this table, the query plan is good or it's really bad. So just to show you, this is basically the stored procedure that I'm using for this test. It declares this table variable, and then doing some select. So pretty straightforward. And what I'm doing now, I'm using a tool called Austria. And now I'm kind of running the same stored procedure twice. Once with, just zoom in maybe. Once with the compatibility level of 130, so SQL 2017, so kind of disabling this new functionality. So let's run it. Sorry. Okay. And in parallel, we will start the performance monitor. And what we figure out, basically what I'm monitoring in the perfmon is just the processor time of the whole server, as well as the SQL Server process. And what you see there is kind of always a spike. So there is, kind of 100% and between 100% and approximately 50%. And it takes some time until this basically the stored procedure is really executed there. So we'll give it some time, and let's have a look if it's already finished. No, still running. What I will use in a few seconds when this thing is has gone through the run, we then will use the query store to analyze the query and to analyze the differences of the query. So just have a look if it's already it's still running. Okay. So it took 1 minute, basically 1.5 minutes to finish. So let's run this with the same stuff, with compatibility level 150. And again, check the query, the performance. So basically what you see here is the performance of the thing is more constant, so there are not that much spikes, and the SQL Server itself is really 100% there. So that's one different when it comes to analyzing really the behavior of this query. But what is more important is of course the time at the end of the day, because by just changing the compatibility level, you bring that down to you bring that down to about 40 seconds. Just the compatibility level, nothing else changed there. And if you really look then into the query plans, you see it there with 2 query plans. You can imagine, okay, this query plan is the query plan that is not performing that well. So we have an average duration of around 4 seconds there, compared to the other query plan, which we have a duration of 600 milliseconds there. And if we look into details, you see why. Let's zoom in there. And you have 2 clustered index scans and a nested loop join, because what SQL Server is estimating here, the estimated number of rows is 1, and SQL Server, yeah, for a number of rows to join, 1 row's nested loop join, yeah, seems okay. So he's predicting the nested loop joins. But at the end of the day, of course, our actual size inside this table is much bigger there. So if you look into the optimized version of the query plan there, we have, in reality, we have 228,000 rows there. And with the new adaptive query processing, we are now kind of adapting the query during the runtime. So we analyze the table variable, say, okay, oh, there is not 1 row, there is the actual number of rows, 230,000, and then we adapt the query plan there. So yeah, you can see it there. So we changed the join to an adaptive join instead of using the nested loop joins, yeah, generating a different query plan that at the end of the day brings this performance. So let's switch back. Yeah, one enhancement I've already mentioned is the enhancement to always encrypted. It's a feature that we introduced with SQL Server 2017. So basically, the idea of always encrypted is to really have data that is encrypted by the application, and SQL Server is not able to decrypt the data. Why would you do that? If you have very sensitive data, personal data, for example, and you don't want even SQL Server to kind of have the theoretical chance to decrypt the data, then you encrypt the data, hold the key only on an application server inside the application, and everything is encrypted end to end. Of course, you only use it for specific columns there, not for a whole table or whole database. There is there's one big disadvantage in that approach. Whenever you're doing queries, you can't query on the server a table, a column that is decrypted. So that's a difficult thing. There was a limited mechanism how you could query the data. So depending on what algorithm you're using, you could kind of decrypt the string what you're searching for as well, send it over to SQL Server, and then of course you can do at least something like compare. You compare basically two encrypted values, and that's possible. But it really depends on the algorithm you're using, because if you're using other algorithms, you can't even do that, do it in that way. So what we're introducing now is a thing that's called enclave, or yeah, secure enclaves we call it, and we're using really the possibilities of the hardware to kind of decrypt the data. So what SQL Server is doing there, it's not really decrypting the server on the server side, but it's really decrypting the server on the hardware side, providing the query, and the hardware decrypts basically the data during the query. So that's a very interesting approach there. So you have again the advantage that SQL Server itself can't decrypt the data, because the software doesn't decrypt it. The hardware thing decrypts the data. So the data itself is encrypted end to end, but you can do more complex query than you would be able to do it now. So that's the main advantage of that, and yeah, I think makes that feature much more useful than it is today, because yeah, being not able to query your data or in a very limited way is yeah, kind of a very big limitation in my point of view. The second thing is a thing that we call data classification. So if you're using a SQL database, you might know that already because we introduced that with Azure SQL Database a long time ago. And now we kind of brought that to SQL Server as well. And with an addition, we can not only classify the data automatically, you can classify it manually, automatically, or a combination of both, and you can audit these tables. So basically the idea is, once you classify your data, you say, okay, this is, for example, an address, this is sensitive data, and then you say, okay, if you audit the data, you audit, for example, select statements, then in your audit log, you can retrieve an information, have someone access sensitive information. So that makes it very easy for the auditing part to kind of review your database activities and review what application or what user is really accessing this sensitive data at the end of the day. So the combination is a very strong thing there. And I would say let's have a look there. So again, I'm switching to the demo. Let's take a look at how you would classify your data. So you just in your SQL Management Studio, just go to your table, to a database, and say discover and classify your data. Then basically you have kind of an initial idea what you could classify. So SQL Server is basically analyzing your data, analyzing especially the content and the naming of the columns there. So I haven't had any classification there. So I now could add manual classification, but I have 29 columns that are recommended for classification. And what SQL Server basically does is especially look at the names of the schema and say, okay, there is for example, a table in the schema application that is an email address, is of the information type contact info and should be confidential, and even more, it's personal information, so it's basically a GDPR compliant thing. And now you can really say, okay, I want to classify this data, and basically let's classify the phone number and the name and so on and so forth. What you can do then is just apply the selected recommendation and save it. Of course, you can always add manual classification on top of that. So you're completely free then what to specify there. You have some predefined information types and sensitivity labels or sensitivity levels, I would call them. And on the one hand, what you can do after you did this classification of your database, one very important thing is, because that's a big ask, is where is my sensitive information stored, or what is my sensitive information at the end of the day? And this is then able to kind of do this with the report. So you have a classification report that analyzes the data. How much of your data is confidential, how much is GDPR kind of sensitive, how much tables are there that contain sensible information, and so on and so forth. So you get a good oversight of your complete sensitive information. And what you can do in addition is really add an auditing to say, okay, now I want audit on a database level, and then you can analyze, okay, who or what is really accessing this sensitive information. So that's then basically the standard auditing. The only thing we did is enhance the auditing with this flag, was there sensitive information accessed. Another thing that's important is that sits inside the task is the vulnerability assessment. So you can now scan your database for database vulnerabilities. And again, this generates a report with, I would say, best practices, findings at the end of the day. And it shows you, okay, we have 6 checks that really failed there. For example, sensitive data, we should classify it, and so on and so forth. So basically what we're doing there is just applying some best practices and showing you where is your database kind of missing or not hitting this best practices. So a very simple thing to just scan your data and say, okay, yeah, this is a thing that I should take care of.
This assessment report is a specific 2019 or this is
I think that's a management studio thing. Yeah, so we can use it for existing SQL servers as well. So basically, the only thing you need is the latest management studio. The only thing I don't know, because I have the preview there, I don't know if it's inside the preview or in the not preview version as well. You need to check. Okay.
This classification of
Yeah.
data, this is also like a per instance, this is stored inside of some information schema, or it's management studio rather?
We basically introduced it with Management Studio, and I think you can use it now with SQL 20, at least with 2017, because the thing is that it need to store it somewhere in the schema, and I don't know if it supports older versions as well, but I'm pretty sure with SQL 2017 you can use it. The auditing part, you need SQL 2019. Okay, with that, we proceed to availability. And as I already told you, if you're running a SQL Server in a Docker container, and especially in a Kubernetes cluster, as of now, you do have a little problem if you want to make it really highly available, because yeah, on the one hand, a container or even Kubernetes is built for microservices and stateless applications, and yeah, the database is stateful. So that was the first problem. Basically, that was addressed with the stateful sets by Kubernetes. So that's basically the underlying technology is now solved that problem for us. Yeah, and now we need to kind of really provide some and hook into this mechanism that Kubernetes provides to really have a full support of always on. So what we're basically doing is similar to what you already know from virtual machines. So when you have different nodes of the Kubernetes cluster and SQL Server sitting into this in these nodes, we now provide an easy functionality to span an always on availability group over these different nodes, and therefore you have a really highly available SQL Server then inside a Kubernetes cluster that was not really available before that. A second thing is that we made additions to online index creation, especially for the clustered column store index. We now provide a possibility to online recreate and rebuild the clustered column store index, or the highly requested feature there. And yeah, already mentioned the availability groups on Kubernetes there. And you can have up to 5 synchronous nodes basically, or 5 synchronous nodes of always on availability groups there. So yeah, one important thing there we did, and there is another enhancement there as well. Because one issue we face with especially legacy applications is the load balancer, so the listener basically. So now you go over this SQL Server listener to access your always on cluster, and that's an issue for some applications that have hard-coded SQL servers in there. So what we basically did is to kind of bypass this thing and do kind of a reverse proxy thing. To not necessarily use the listener, but to kind of redirect then the server to another always on instance as well. So this is a second enhancement we did with the always on availability groups. Yeah. So this is going through the load balancer. So in terms of development, already mentioned the SQL Server data tools, and already mentioned the possibility that you can now run Java code within SQL Server. Also a very interesting choice. So basically what we did, we enhanced this possibility of this machine learning servers, or basically we took this mechanism of machine learning server, and I don't know if you're really familiar how it really works behind the scenes. So what we are doing is, and that's one major difference if you're running extended stored procedures or CLR stored procedures, because these two types, I would call the version 1 of this stuff, is really running within the SQL Server context and in the SQL Server process. So it adds a lot of things there if it runs in the same process. Security is one big constraint there. Performance if everything runs in one process, and so on and so forth. So to kind of do it in a different way, we introduced this with the R server and machine learning server. We basically have a process that is called the launchpad. It's an own process. We have the SQL Server process, of course. And whenever we run this kind of external code or this managed code, our launchpad launches an own process there that is kind of a child process of the SQL Server process. So the idea behind it is really isolated in an own process, but it really can talk directly to the SQL Server without accessing the data like an external application. So it can directly access the data there. It's very performant, of course, but you have not this problem that everything runs in one process there. So this is how this basically is working. And another advantage is that you can use Resource Manager to kind of govern the resources of SQL Server. So if you need to kind of limit the resources for this external code, you can do this using SQL Server Resource Governance. Yeah, and what we've added with SQL 2019 is basically Java. There are some other enhancements as well. Besides the Java extension, for example, UTF-8 support was already also a highly requested stuff a long time. We did some enhancement with regards to SQL Graph. Pretty new thing, not that much used as of now. I don't know if anybody experienced did some experiments with SQL Graph. The idea is not to have another graph database. That's would be the wrong approach, but to have really a kind of graph-like query language on top of your relational tables. So especially if you have queries that need to kind of go a lot of do some more difficult queries in terms of I want to query that person that is related to that person that is related to whatever. So a typical graph query, then you can do this on your relational database, on your relational tables, just by adding or just by using this T-SQL extension of SQL Graph. So again, the idea is not to kind of build a graph database because there are specific technologies that work better and more performant. The idea is to give you a choice in T-SQL to write or this type of specific queries, not in traditional T-SQL, because you're breaking your fingers, basically, if you're trying to do such queries with standard T-SQL. I will show you maybe the Java thing, because that's a funny thing. So what you basically need to do if you want to query the Java stuff is basically you need to enable. Just a second, I'll show you how I do it. Java. You need to show advanced options, enable this external script. So it's basically the same as you would do it for Python and for R. So this is basically the thing. Of course, you need to install this through the SQL installer or PowerShell or whatever, the machine learning part of SQL Server to execute this. And in terms of Java, that's a little bit different of when it comes to Java than it is in Python or in R. You need to install the Java runtime then on the server, of course, otherwise SQL Server can't execute the stuff. Need to add some variables there, but pretty straightforward. And then at the end of the day, what you're doing is you just compile your Java code. So let's have a look into this into this Java code. What I'm doing there is kind of a classification there. So yeah, without having looking too much into detail what the code actually does. It's using kind of a model to classify data, which is basically not really possible with T-SQL at the end of the day. So what you basically need to do is you write the Java code, then you just compile it. To run it, pretty straightforward. You just say, okay, where is my Java code located? And the only thing you have to take into account, the SQL Server process or some specific users that are documented need to access this this library or need to access this path. One thing you have to take into account, I don't know why, but this class path is limited to 50 characters. That's what I was struggling with, because it just cuts the path. I have no idea why 50 characters. I mean, for a path, whatever. Yeah, I hope it's preview. No, I think it was there before. So the limitation of 50 characters of the path. Yeah, whatever. And then you just call, as you would do it for Python or the R script, you just execute the stored procedure, execute external script, language Java, of course, and then you just specify the class you want to call and the path and provide the path. And basically that's it. So you just, let's run the stuff. And basically what this Java function does, it takes the data and it builds a classification there. Yeah. So just for this sample. But that's really a very easy way to kind of take Java code and execute it within the SQL context. And the advantage here is, from my point of view, is that at the end of the day, you can directly access your data. So basically, you don't need to have an application that kind of accesses the data through JDBC or whatever. It runs really in the context of SQL Server on the server, and you don't need to kind of deal how you would access the data from an external stuff. So you can really perform in database analytics with Java at the end of the day, or in database actions with Java. Okay. Yeah, one thing I was missing out through my demo of the query profiling is the lightweight query profiling, just to show that to you as well. Let's close that. Yeah, and by the end of the day, what I'm using here is the Azure Data Studio. So as I already mentioned, yeah, it's in terms of functionality, of course, it's kind of limited now, but it's really yeah, a very early and young version of the SQL Data Studio. Of course, you can access your servers there. You can do queries, have some basic overview of your servers, do some backup, restore, and all this stuff. So basically, of course, you can do everything what you can do within T-SQL, but in terms of in terms of the GUI, there are some limitations. So still, in terms of management, you will use Management Studio most of the time, to be honest. But one advantage is you're really independent on the operating system, so you can use it on a Mac as well. So you can expect that we put a lot of investment there to kind of really catch up in terms of features with the Management Studio there. What I wanted to show you is a very nice and very simple example of how you can use this live query analytics. So that's really a thing that in SQL 2017 you really need to activate it. Now it's activated out of the box, and just to give you an idea why this could be useful. For example, if we have this stored procedure here, or this query here, and I'm doing the same thing what I did before. So I just run this with the Austria. Good. Yeah, edit. Oops. So running now. And if we change now to Management Studio, let's do an, let's check the activity monitor. So if you're checking the activity monitor, you have a pretty high percentage of processor time, nearly 50%. You wouldn't expect for that kind of really simple query, because what the query does is basically join an inner join to another table and select. So that's pretty very basic at the end of the day. So there is something wrong with the query. As of now, you couldn't really do a lot of things to figure out what is wrong with the query at the end of the day. So of course, you could analyze basically the statement itself, but if it's a more complex statement, you have no idea what SQL Server is doing. And this is what we are addressing with the live query stuff. So if you look now here into the expensive query, the query is already listed here. And I'm just out of the activity monitor now show the live execution plan. So what I'm getting there is this live view of the really actual execution plan there. And what you're seeing here is pretty interesting, because we're doing 2 index scans on the same table and joining that. That's pretty weird. And that's causing, of course, a lot of is using a lot of performance there. And if you look more into detail of this query, what we did here is we joined ourselves basically. So instead of using the other table for the joins, we're using our own ID and joined to ourselves. And that's causing, of course, a strange behavior there. So at the end of the day, this is just to show you how you really can now debug the stuff in real time without adding the stuff. Because nowadays, if you haven't turned the stuff on, you're kind of really blind on one eye. I mean, you can try to kind of figure out why could this query be a problem, but now you really get always the actual query plan, and now you have more hints to what might be wrong or what might be happening in my SQL Server. And of course, you can then say, okay, this was process number 68, I think. And I now want to kill the stuff. And now you go back to the developer and say, okay, please fix that. So kill that stuff and the query is gone. Okay. Okay, then coming to an end. Again, the enhancement of the platform choice when it comes to Linux, we are kind of closing the gaps to the Windows implementation of SQL Server, especially when it comes to other services, because for the database engine, the compatibility is basically there already. But when it comes to machine learning, other functionality like replication, and so on and so forth, there are some limitations there. So in Linux, you have basically the core engine of SQL Server, so the database itself, and you have integration services. And we are now bringing transactional replication to Linux as well in all combinations. We support, is one of the most important things for application is distributed transactions. So every applications that was using distributed applications didn't work with SQL on Linux. It works now with SQL 2019. And we introduced machine learning. So now we fully support machine learning services on Linux as well. Enhance that as well. Okay, so basically, these are some details with regards to tuning. I would say there's a lot of details that happens, of course, behind the scenes as well. So really some highly requested stuff like column store statistics in the DBCC clone database, and some other stuff there as well. I already mentioned the Azure SQL Data Studio. The interesting thing, it's similar to Management Studio now. It's decoupled from the versions, so we basically will bring out their new functionality, in a short term there. So it absolutely makes sense to periodically look at SQL Data Studio as well and how far it is. Skip that. So if you want to try out SQL Server, there you basically have two options, I would say. You can download it, of course, from our page. Link there is in the in the PDF. So preview is publicly available for Linux, for containers, for Windows, of course. One easy way, if you don't want to set up your own virtual machines, is just using Azure virtual machines. Virtual machines, we have pre-installed templates there. You just kick off a virtual machine and decide, do we want it on Linux or Windows, and off you go. If you're interested in the early adopter program for the big data cluster, then you can sign up here for this early adopter program. And of course, we added and refreshed all our documentation to reflect all the changes, where a lot of details are explained there.